Hi, here I am testing the smart motion control features of this Trinamic motor. Over this setup, from here I have the 12-volt main supply coming in, wherein it's powered to the motor, and this MotionPy board again acts as a CAN bridge, and it's powered by the USB. Looking into these probes, I have connected across the coils. Over here there are 4 connections coming from the coils. They are A1, B1, A2 and B2, which are the common generic connections of a bipolar stepper motor. So the mains of the probe goes into A1 and B1, A2, B2 are grounded. I am making this full test and measurement using this Raspberry StemLab board. Let's now go into the monitor, launch TMCL IDE and look into the controlling of the motor. Here over the TMCL IDE, I have connected the MotionPy board and we have the motor initialized. Let me expand over this, and looking into the velocity mode, we get this nice little motion control graph wherein I can control the target velocity and also the acceleration. So as I've already probed the setup, I can look into the waveform now. As we see here, this is the input 1 channel and input 2 channel. For input 1 channel, I have connected A1, A2 of the stepper motor, and 2 goes to B1, B2. So there is a little bit of noise and ripple with the channel number 2, which is not very unusual to see in stepper motors, but with the help of Trinamic's smart control feature, we can mitigate that. So let's look into the chopper settings. And over here, I'm going to StealthChop. Let me minimize and show things live. So we are still seeing the ripple, and the motor is in 0 velocity and just powered up. And when I enable StealthChop, the humming noise of motor has stopped, and also we see pure little smooth waveform between 2 coils. So now there is a normalization and the motor is also silent. This is what Trinamic claims suitable for indoor usages. Next, let me quickly disable this and go back. Let's go into the velocity mode. Okay, we are already in it, and I'm slowly increasing the target velocity, that is turning on the motor. We can see over the meter here, it's increasing little by little, and I'm resuming the motor. Now the motor has started to pick up the speed. More. Okay, at this point the motor has just started to pick up the speed, and let's see the waveform. Okay, the coils are still not completely magnetized, or the current is not fully flowing through them. Let me keep in the same minimization tab and increase this velocity a bit more. It's cranking up. Okay, there we have. It's common to see this a lot of ripple during the starting and initialization phase of the motor, but eventually it smooths down and we can see the clear waveforms. So I'll keep it in the same minimized way and possibly set the motor to constant speed. Okay, looks like it's set now. There is a little bit of humming noise in background, just ignore that. Okay, so now let me quickly maximize this and once go to the chopper settings again, and we have a nice feature called StealthChop. So this StealthChop is basically it completely silences the motor by eliminating noise caused from unsynchronized motor coil chopper operation or jitter in PWM. It's a voltage regulated chopper method and modulates the current based on PWM signal and minimizes the ripple a lot. So in also this spread cycle feature is another add-on with this Trinamic. So in the high speed mode of chopper settings, let me go and tweak few parameters to set these ripples. So we still see the ripples. It's not the very ideal waveform which you see on the textbooks or which we learned. Okay, I'll keep the time scale same and enable the high speed chopper ripple. And now the motor seems to be smoothened up and the humming noise has quietly, slightly denoised. Let me also enable this high speed full step mode and closely observing into the waveform, we can see it has improved a lot. So now there are no ripples. It's almost like a pure waveform controlling the stepper motor. So below one is the B1 and B2 coil, and in one, that is the channel 1 is A1 A2 coil. So I have all the modes enabled and it's fully optimized. You can see a clean waveform. It's moving and purely visible. The motor is also, it's not vibrating over my table. Earlier it was causing some humming noise and buzzing all over. So if I disable this back, see the ripple hacks has come up. I can stop this and probably analyze this a bit. So if I zoom in, we see the ripple at the rise up and also over the steps in the channel into coil. If I disable both, the condition is going to be worsened. Yeah, so this is all over ripple, not all a good one, and as we enable these features, things are smoothened and operating nicely. This is a cool feature. I really liked it, and the motor is now very beautifully running.